Okay, good morning my dear students. In this class I am going to explain expression for the torque experienced by an electric dipole in a uniform electric field. Here in the previous classes already I have discussed what is electric field and types of electric field. Electric field can be divided into two types, uniform electric field and non-uniform electric field. Here electric dipole in a uniform electric field. Here expression for torque experienced by an electric dipole. Here the electric dipole placed in a external uniform electric field. And the electric dipole is placed in a external electric field. It produces a certain torque. Torque it is nothing but twisting force. Already in the first PUC classes already we have studied what is torque and what is the SI unit of torque and the conditions of torque. Here in this class I am going to discuss torque produced due to an electric dipole when it is placed in a external electric field. Here suppose I have considered here the external electric field, the uniform electric field. See the uniform electric field. Here this uniform electric field, it is produced by any other source. This is the reason of uniform electric field. This is the reason of uniform electric field. It is produced by any other source. Here this is the reason of uniform electric field. In this uniform electric field, suppose now I place electric dipole. Electric dipole means a pair of equal and opposite charges. Pair of equal and opposite charges separated by a small distance. Here in this uniform electric field, now I place an electric dipole. Now I place the electric dipole. This is an electric dipole. Electric dipole means it is a pair of equal and opposite charges separated by a small distance. Here this is the negative charge and this is positive charge. A pair of equal and opposite charges separated by a small distance, that is 2a. In this uniform electric field, now I place an electric dipole. Here, when this electric dipole is placed in the region of uniform electric field or in external electric field, here it produces a certain torque. It produces a certain torque which makes a certain angle theta. Which makes a certain angle theta. Here, force acting on this charge particle. The force acting on this charge particle. The force acting on this charge particle, that is due to the positive charge particle. Force acting on this charge particle, that is Q into E. The force acting on this charge particle due to this positive charge. Here, force acting on this charge particle, it is along the direction of the electric field. It is always along the direction of electric field. But force acting on this negative charge it is anti-parallel to the direction of the electric field. That is minus Q into E. Minus Q into E. Force acting on this positive charge is Q into E or plus Q into E. Force acting on this negative charge is minus Q into E. Here, due to this electric dipole, here the torque is produced. Torque it is nothing but twisting force. Here, these two charges are equal in strength but opposite in charges. Equal in strength but opposite in charges. Due to these opposite forces. Due to these opposite forces here, which makes a certain angle theta. Here, this is called a couple of force. This is called a couple of force, or it is nothing but twisting force. Torque it is nothing but twisting force which makes a certain angle theta. Now, here the net force acting on this particle is 0. But here the couple of force is present due to these opposite charge particles. Due to this opposite charge particle. Force acting on this positive charge is F is equal to Q into E along the direction of the parallel. Along the direction of the electric field or parallel to the direction of the electric field. Force acting on the negative charge is anti-parallel to the direction of electric field. Here, now I am going to calculate the torque experienced by an electric dipole. This is the electric dipole. And this electric dipole placed in the region of uniform electric field here, the torque is produced. You know the formula. Torque is equal to, here, torque is equal to couple of force. Torque is equal to couple of force into perpendicular distance between two forces. It is the torque formula. Here, torque is equal to couple of force into perpendicular distance between the two forces. Here, the perpendicular distance between these two forces. Here, now I make or draw this certain triangle. This is the perpendicular distance between these two forces. Here, theta is equal to 90 degree. Here, this is the one triangle. Here, this is triangle ABC, which makes a certain angle theta. Here, the distance between these two poles, that is 2a. Torque is equal to couple of force into perpendicular distance between the two forces. Here, the couple of force, that is F is equal to Q into E. Here, these two charges are equal in magnitude but opposite in charges. Then I write here torque, tau is equal to force F or here Q into E. Q into E into perpendicular distance. Perpendicular distance. Here, the perpendicular distance, that is BC. The perpendicular distance, that is BC. Torque QE into BC. But here, from triangle ABC, here for this triangle ABC is equal to, here BC is equal to AB sin theta. BC is equal to AB sin theta. But the distance between A to B, that is 2A. Now BC is equal to 2A into sin theta. BC is equal to 2A into sin theta. Substitute this value here. This is equation number 1 and this is equation number 2. Now substitute equation 2 in equation number 1. You get torque is equal to QE into 2A sin theta. Torque is equal to, here tau is equal to Q into E into 2A sin theta. But you know the formula. Dipole moment. Dipole moment means it is the product of strength of the either pole and dipole length. Here, now we can write this equation. Tau is equal to, here, Q into 2A into E sin theta. Tau is equal to Q into 2A into sin theta. Here, it is in the form of dipole moment. The strength of the either pole and, here, Q into 2A. Strength of the either pole and dipole length. Tau, torque is equal to Q into 2A into E sin theta. Then finally you get torque is equal to P into E into sin theta. Torque is equal to P into E into sin theta. It is in the form of A cross B. A cross B is equal to AB sin theta. Now you get torque. Vector torque is equal to vector P cross vector E. Tau is equal to P cross P. When the torque is maximum, suppose if theta is equal to 0 degree, sin 0 degree value 0, then the torque is minimum. If theta is equal to 90 degree, sin 90 value 1. When the torque is maximum, in this case, if theta equal to 90 degree, torque is maximum. When this electric dipole is perpendicular to the direction of electric field, torque is maximum. When the theta is minimum, if theta is equal to 0. If theta is equal to 0, the torque is minimum. If theta equal to 90 degree, torque is maximum. Here, this is expression for torque experienced by an electric dipole in a uniform electric field here. This is the region of uniform electric field. Throughout this region, the electric field is constant. Here, this is arrangement by any other process. This is the external electric field. In this external electric field, now I place a electric dipole. When the electric dipole placed in the region of electric field, it produces a certain torque. When the torque tau is equal to PE sin theta. When the torque is maximum, when theta is equal to 90 degree, the torque is maximum. When theta is equal to 0 degree, torque is minimum. Suppose I express this equation in the form of vector tau is equal to vector P cross vector E. Here P is equal to, this is dipole moment, E electric field, theta it is the angle between the two forces, which is the expression for torque experienced by electric dipole in the region of uniform electric field. Thank you.